Today, our group is going to present about our assignment. We have been instructed by our lecturer to present our product that we want to present. Okay, we're going to introduce ourselves. My name is Ahmad Ashri.
My name is Muhammad Fernanda.
And my name is Muhammad Haris bin Muhammad Sukri.
Okay, this is our group members. I will present first. Okay, introduction. Torsion refers to the twisting of a straight bar when it is loaded by a moment or torque that tend to produce rotation about the longitudinal axis of the bar. Its effect is of primary concern in the design of drive shaft used in the vehicles and machinery. And for this reason, it is important to be able to determine the stress and the deformation that occur in the shaft when it is subjected to torsion loads. The objective of this assignment is to determine the behavior of the material when twisted or torsion force given, to display the calculation of shear stress or of circular shaft subjected to torsional loading, and determine the equation of equilibrium EOE from FBD.
Okay, next is we can see the actual ceiling fan and the free body diagram is shown in the poster. Okay, next. Start. Okay. For the information of ceiling fan, the length is 711 millimeter, weight is 5 kilo, and height is 460 millimeter. Length for the fan blade is 340 millimeter, and the material it made is steel. And for the force at the top of the fan is 30 Newton, and the bottom is also 30 Newton, and the shear modulus G equal to 77.2 gigapascal. So for the equilibrium, we get the tension is 42.66 nanometer. We also calculate the shear stress and we get 63.99, and the polar moment we also calculate, we get 0.199. For the T max, we get 144.475 Pascal, and the T allow we get 76.32. We also calculate the angle of twist equal to 1.97 times 10 power of negative 9 radian. And from the T max and T allow, we calculate the factor of safety, which is 1.893. Okay, next.
Tak tukar kan? Okay. So discussion based on this project, we have discussed about the weight, dimension, force and radius of the ceiling fan. We assume all that based of our theory and Google. Then from the data, we calculate the polar moment of inertia. We also calculate the torque max and torque low, so that we can use it to factory safety. For the torsion, we calculate the angle of twist. The problem that we had during doing this project is we must assume ourselves the normal force and the the under fence force. We assume it have 30 Newton for the normal force, and the 30 Newton must also have the same force as if under force to make equilibrium and static on the top of ceiling. The factor of safety we calculate it from the torque max and torque low from data. So the conclusions in a nutshell of this project, we're able to draw a free body diagram of the ceiling fan structure and determine its force and all the dimension of the ceiling fan. Next, we also get to know on how to calculate the shear stress and the polar moment of the ceiling fan. In our last word, we apply all the theory about the ceiling fan based on the mechanic solid topic. The project teach us a lot of things. For example, we can observe on how the ceiling fan hang on the top of ceiling and is safe or do not fall to the ground. That's all from me.
That's all from our group. Thank you.
You